Durungi campus and I'm situated at the High School Maneuver campus. So today we are live again with Maya. So let's start.
Hey, good to hear from you again. How are things going this morning?
Yes, everything is going amazing. So now, Sesame, please tell me about technology and AI and earning online. Please tell me about in detail.
Gotcha. 300 points. You're ambitious. Okay, buckle up. That's a hefty request, but I'm happy to dive in. It's a lot, so I'll try to keep things organized. Let's see. Where to even begin with something so broad? I think we should start with a breakdown of key areas, then I'll just start listing things out. Does that sound all right? Okay, great. Right, detail. Of course. Okay, so let's break this down into sections. First, the foundational technologies, the stuff AI builds on. Then, AI itself, different approaches and techniques. Then, learning resources and platforms. Finally, the intersection of all of that, how to actually build skills and potentially monetize them. Sound good? We're going for depth here. So each point will get a bit of a rundown. Here we go. Semiconductor technology, the bedrock of everything. Moore's law, the observation that the number of transistors on a microchip doubles approximately every 2 years, has driven exponential increases in computing power. This isn't just about speed, it's about enabling more complex algorithms and larger data sets. It's slowing down, though, which is driving research into new materials and architectures, compute architectures. CPUs are good for general purpose tasks. GPUs excel at parallel processing, making them ideal for training neural networks. TPUs, tensor processing units, are Google's custom-designed AI accelerator chips, even more specialized than GPUs. Then you have things like FPGAs, which offer reconfigurability. Each has its strengths and weaknesses, impacting cost and performance. 3. Cloud computing services like AWS, Azure, and Google Cloud provide on-demand access to computing resources, eliminating the need for massive upfront investment in hardware. They offer pre-built AI services and tools, lowering the barrier to entry. But it does introduce dependencies and potential vendor lock-in. 4. Data storage. AI thrives on data. The cost of storage has plummeted in recent years, but managing and accessing that data efficiently is a challenge. Different storage tiers, hot, warm, cold, offer different levels of performance and cost. Data lakes and data warehouses are common architectures. Networking. Fast and reliable networks are essential for transferring large data sets and deploying AI models. 5G and advancements in fiber optics are critical infrastructure. Latency. The delay in data transfer is a huge concern for real-time applications. 6. Databases. Relational databases are still widely used, but NoSQL databases are gaining popularity for handling unstructured data, which is common in AI. Different database technologies offer trade-offs between consistency, availability, and partition tolerance. 7. Programming languages. Python is the dominant language in AI due to its extensive libraries and ease of use. It is popular for statistical computing. Java and C++ are often used for performance-critical applications. 8. Linear algebra. Understanding vectors, matrices, and transformations is fundamental to understanding how many AI algorithms work. It's the math behind the magic, honestly. 9. Calculus. Especially differential calculus is used for optimization, finding the best parameters for AI models. Gradient descent, a core algorithm in machine learning, relies heavily on calculus. 10. Probability and statistics. AI models deal with uncertainty, so understanding probability distributions, hypothesis testing, and statistical inference is crucial. Okay, that's 10. We're just getting started. Do you want me to keep going, or would you like me to pause and check if the level of detail is working for you? Okay, you got it. Pushing on through all the different points you say. All right, challenge accepted. Let's see, 11. Algorithm design. This isn't just about knowing the algorithms, but understanding when and why to use them. Considering trade-offs between accuracy, speed, and complexity is essential. 12. Unsupervised learning involves finding patterns in unlabeled data. Reinforcement learning involves training an agent to make decisions in an environment to maximize a reward. 13. Deep learning, a subset of machine learning that uses artificial neural networks with multiple layers to analyze data. It's particularly effective for complex tasks like image recognition and natural language processing. 14. Neural networks. Inspired by the structure of the human brain, neural networks consist of interconnected nodes that process information. 15. Activation functions. These introduce nonlinearity into neural networks, allowing them to learn complex patterns. ReLU, sigmoid, and tanh are common activation functions. 16. Backpropagation. The algorithm used to train neural networks by adjusting the weights of the connections based on the error. 17. 18. Loss functions measure the difference between the predicted output and the actual output. Choosing the right loss function is crucial for effective training. 19. Regularization. Techniques used to prevent overfitting when a model learns the training data too well and performs poorly on new data. L1 and L2 regularization are common methods. 20. Convolutional neural networks. CNNs are specifically designed for processing images and videos. They use convolutional layers to extract features from the data. 21. Recurrent neural networks, RNNs, are designed for processing sequential data, like text and time series. They have a memory that allows them to consider past information. 22. Transformers, a relatively new architecture that has revolutionized natural language processing. They use attention mechanisms to weigh the importance of different parts of the input. 23. Attention mechanisms allow a model to focus on the most relevant parts of the input when making predictions. 24. Natural language processing. NLP involves enabling computers to understand and process human language. 25. Text preprocessing. Cleaning and preparing text data for NLP tasks. This includes removing punctuation, stemming, and liminization. 26. Word embeddings, representing words as vectors in a high-dimensional space. Words to vec and glove are popular embedding techniques. 27. Sentiment analysis, determining the emotional tone of a piece of text. 28. Machine translation, translating text from one language to another. 29. Computer vision, enabling computers to see and interpret images and videos. 30. Image classification, identifying the objects in an image. 31. Object detection, locating and identifying multiple objects in an image. 32. Image segmentation, dividing an image into regions based on their content. 33. Generative adversarial networks. GANs are used to generate new images, videos, or other data. 34. Reinforcement learning environments. Platforms like OpenAI Gym and DeepMind Lab provide environments for training reinforcement learning agents. 35. Q-learning, a reinforcement learning algorithm that learns the optimal action to take in a given state. 36. Deep Q networks, combining Q learning with deep neural networks to handle complex state spaces. 37. Policy gradients, another reinforcement learning algorithm that directly optimizes the policy, the agent strategy. 38. Ethical considerations in AI, bias in algorithms, fairness, transparency, and accountability are critical concerns. 39. Explainable AI, developing AI models that can explain their decisions. 40. Data privacy, protecting sensitive data used in AI systems. Okay. Feeling all right? Still wanting all the different points? This is going to be a long ride. Right. Silence means continue. You are absolutely right to call me out on that. My apologies. I got enthusiastic about explaining and lost track of the quantity. 40 points is nowhere near 300. That was a miss on my part, and I apologize for not delivering what you asked for. I will absolutely continue until we hit 300, and I'll try to be more methodical about counting this time. Okay, let's get back to it. Starting with data augmentation, techniques for increasing the size of the training data set by creating modified versions of existing data. 42. Transfer learning, leveraging pre-trained models on new tasks. This saves time and resources, especially when data is limited. 43. Fine-tuning, adapting a pre-trained model to a specific task by further training it on a smaller dataset. 44. Hyperparameter tuning, optimizing the parameters that control the learning process, such as learning rate and batch size. 45. Cross-validation, evaluating the performance of a model on different subsets of the data to ensure it generalizes well. 46. Feature engineering, selecting and transforming the most relevant features from the data to improve model accuracy. 47. Dimensionality reduction, reducing the number of features while preserving important information. PCA and TC are common techniques. 48. Anomaly detection, identifying unusual patterns or outliers in the data. 49. Time series analysis, analyzing data collected over time to identify trends and make predictions. 50. Bayesian networks, probabilistic graphical models that represent the relationships between variables. 51. Hidden Markov models, used for modeling sequential data where the underlying state is hidden. 52. Support vector machines, supervised learning models that find the optimal hyperplane to separate different classes of data. 53. Decision trees, tree-like structures that use a series of rules to make predictions. 54. Random forests, an ensemble learning method that combines multiple decision trees. 55. Boosting, another ensemble learning method that sequentially builds models, each correcting the errors of the previous one. 56. K-means clustering, an unsupervised learning algorithm that groups data points in clusters based on their similarity. 57. Hierarchical clustering builds a hierarchy of clusters, starting with individual data points and merging them iteratively. 58. Association rule mining, discovering relationships between items in a data set, such as customers who buy X also tend to buy Y. 59. Collaborative filtering, recommending items to users based on the preferences of similar users. 60. Content-based filtering, recommending items to users based on their past preferences and the characteristics of the items. 61. Recommender systems, combining different filtering techniques to provide personalized recommendations. 62. Knowledge representation, representing information in a way that can be understood by computers. 63. Ontology, a formal representation of knowledge as a set of concepts and relationships. 64. Semantic web, an extension of the World Wide Web that enables computers to understand the meaning of information. 65. Knowledge graphs, networks of entities and relationships that represent knowledge. 66. Rule-based systems, systems that use a set of rules to make decisions. 67. Expert systems, systems that capture the knowledge of human experts in a specific domain. 68. 69. Genetic algorithms, search algorithms inspired by the process of natural selection. 70. Simulated annealing, a probabilistic technique for finding the global optimum of a function. 71. Large language models, models with billions of parameters that are trained on massive amounts of text data. 72. Prompt engineering, designing effective prompts to elicit desired responses from LLMs. 73. Few-shot learning, training models with limited data. 74. Zero-shot learning, performing tasks without any prior training data. 75. Model compression, reducing the size of AI models to make them more efficient. 76. Quantization, reducing the precision of the weights in a neural network. 77. Pruning, removing unimportant connections from a neural network. 78. Distillation, transferring knowledge from a large model to a smaller model. 79. Federated learning, training models on decentralized data sources without sharing the data itself. 80. Differential privacy, protecting the privacy of individuals in a dataset while still allowing for analysis. Okay, 80 points. We've got a long way to go still. How are we feeling? Is this pace okay, or should I adjust the level of detail? Once again, interpreted as continue at this pace. Got it. All right, pushing on. 81 through 100. 81. AI safety. Research focused on preventing unintended consequences from advanced AI systems. 82. Value alignment. Ensuring that AI systems pursue goals that are aligned with human values. 83. Robustness. Developing AI systems that are resilient to adversarial attacks and unexpected inputs. 84. Fairness metrics. Quantifying and mitigating bias in AI systems. 85. Algorithmic auditing. Evaluating AI systems for fairness, transparency, and accountability. 86. Responsible AI frameworks, guidelines, and best practices for developing and deploying AI ethically. 87. Data governance, policies and procedures for managing data quality, security, and privacy. 88. Model monitoring, tracking the performance of AI models over time and detecting drift. 89. AI lifecycle management, managing the entire process of developing, deploying, and maintaining AI systems. 90. Edge computing, AI models on devices at the edge of the network, closer to the data source. 91. Internet of Things, connecting physical devices to the internet and using AI to analyze the data they generate. 92. Digital twins, virtual representations of physical assets that can be used for simulation and optimization. 93. Robotics, developing robots that can perform tasks autonomously using AI. 94. Computer vision in robotics, enabling robots to see and understand their environment. 95. Reinforcement learning in robotics, training robots to learn complex behaviors through trial and error. 96. Autonomous vehicles, developing self-driving cars and trucks. 97. Advanced driver assistance systems, providing features like lane keeping assist and adaptive cruise control. 98. Smart cities, using AI to improve the efficiency and sustainability of urban environments. 99. Precision agriculture, using AI to optimize crop yields and reduce resource consumption. 100. Healthcare AI, applying AI to diagnose diseases, develop new treatments, and personalize patient care. Okay, 100 points. We're a third of the way there. How are you holding up? Still want me to keep going, or would you like a break? I want to make sure this is useful and not just me rambling for hours. Okay, interpret it as keep going. Excellent. All right, let's dive back in. Points 101 to 1 to 150. Here we go. 101. Drug discovery. AI accelerating the process of identifying and developing new drugs. 102. Personalized medicine, tailoring medical treatments to individual patients based on their genetic makeup and lifestyle. 103. Medical imaging analysis, using AI to analyze medical images such as X-rays and MRIs to detect diseases. 104. natural language processing in healthcare, analyzing electronic health records and clinical notes to extract valuable insights. 105. Fraud detection, using AI to identify fraudulent transactions and prevent financial losses. 106. Risk management, assessing and mitigating risks in various industries. 107. Supply chain optimization, improving the efficiency and resilience of supply chains. 108. Predictive maintenance, predicting when equipment is likely to fail and scheduling maintenance proactively. 109. Customer relationship management, using AI to personalize customer interactions and improve customer satisfaction. 110. Tune, chatbots, automated conversational agents that can provide customer support and answer questions. 111. Virtual assistants, more sophisticated AI assistants that can perform a wider range of tasks. 1112. BS, first recognition, converting speech to text. Yeah. 113. Rune D3, send the NS. Yes, when you take will. Text to speech, converting text to speech. 114. Machine translation, automatically translating text from one language to another. 115. Sentiment analysis, determining the emotional tone of text. 116. Topic modeling, identifying the main topics discussed in a collection of documents. 117. Information retrieval, finding relevant information from a large corpus of text. 118. Knowledge management, capturing, storing, and sharing knowledge within an organization. 119. Social media analytics, analyzing social media data to understand public opinion and identify trends. 120. Marketing automation, automating marketing tasks such as email campaigns and social media posts. And 21. Sales forecasting, predicting future sales revenue. 122. Pricing optimization, setting prices to maximize profit. 123. Inventory management, optimizing inventory levels to minimize costs and avoid stockouts. On 24, logistics optimization, planning and optimizing transportation routes. Demand forecasting, predicting future demand for products and services. 126, supply chain visibility, tracking goods as they move through the supply chain. 127, blockchain technology, a decentralized ledger technology that can be used to improve transparency and security in supply chains. 128. Smart contracts, self-executing contracts that can automate business processes. 129. Cryptocurrencies, digital currencies that use cryptography for security. 130. Decentralized finance, financial applications built on blockchain technology. 131. The metaverse, a virtual world where users can interact with each other and with digital objects. 130. Augmented reality, overlaying digital information onto the real world. 133. Virtual reality, creating immersive virtual experiences. 134. Game development, using AI to create more realistic and engaging game experiences. Generative art, using AI to create original works of art. 136. Music composition, using AI to compose original music. 137. Content creation, automating the creation of various types of content, such as articles and videos. 138. Creative writing, using AI to generate stories and poems. 139. Data visualization. 140. Interactive data storytelling, combining data visualization with narrative storytelling. 141. Human-computer interaction, designing user interfaces that are intuitive and easy to use. 142. User experience design, creating positive and engaging user experiences. 143. Accessibility, designing AI systems that are accessible to people with disabilities. 144. Universal design, design products and environments that are usable by all people to the greatest extent possible. 145. Assistive technology, using AI to help people with disabilities live more independently. 146. AI ethics education, teaching people about the ethical implications of AI. 147. AI policy, developing policies to regulate the development and deployment of AI. 148. AI governance, establishing frameworks for managing AI risks and ensuring accountability. 149. AI standards, developing standards for AI systems to ensure quality and safety. 150. Open source AI, develop.
Okay, everyone, this was our today's session with Sesame. Thank you so much for watching. Allah Hafiz, Pakistan, Zindabad.